Generally, all dual brake valves function the same way. Mounting methods may differ. This is the floor-mounted E6, and this the firewall-mounted E7. We'll use the E6 to look at the major components of a dual brake valve. The actuation components of the E6, pedal or treadle, plunger, roller, stop button, boot, and fulcrum pin are interchangeable with other brake valves. The internal components are spring seat, graduating spring, primary piston, primary inlet and exhaust valves, secondary or relay piston, and secondary inlet and exhaust valves. Air from each reservoir enters its respective supply port on the brake valve. Because the circuits are normally closed, air does not pass through the valve until a brake application. The delivery ports are open to the exhaust at atmospheric pressure, shown in yellow. With a brake application, the treadle is depressed, and the plunger applies a force on the spring seat. This compresses the graduating spring, and in turn causes the primary piston to move. The primary piston, which incorporates the exhaust valve seat, closes the primary exhaust valve. As the exhaust valve closes, the primary inlet valve is moved off its seat, and air from the primary service reservoir flows out the primary delivery port. Air from the primary delivery passes through the bleed passage and enters the relay piston cavity. Primary delivery air pressure moves the relay piston, which incorporates the exhaust seat, and closes the secondary exhaust valve. After the secondary exhaust valve closes, the secondary inlet valve is moved off its seat, and secondary reservoir air flows out its delivery port. A balanced position in the primary circuit is achieved when the primary air pressure beneath the piston exerts a force equal to that of the driver's foot on the brake treadle. The primary piston moves slightly, closing the inlet, preventing further air delivery. In this position, the secondary circuit reaches a balanced position. Air pressure on the primary and secondary sides of the relay piston equalizes. As this balance is attained, the relay piston moves, closing the inlet and preventing further air delivery. When the treadle is fully depressed, as in a panic stop, both circuits are held open mechanically and full reservoir pressure is delivered. When the brake treadle is released, the mechanical force is removed from the spring seat, graduating spring, and primary piston. Air pressure and spring load move the primary piston. The exhaust opens, and air pressure in the primary circuit goes out the exhaust port. As the air is exhausted from the primary side of the relay piston, air pressure and spring load move the relay piston, opening the secondary exhaust. If air pressure is lost in either circuit, the portion of the brake valve that still has air pressure supplied to it will continue to function. However, should air pressure be lost in the primary system, the relay piston will move by mechanical force from the driver's foot, not from air pressure delivery from the primary circuit.